Welcome to Maths Way channel. Another past question on coordinate geometry from Oxford and Cambridge past paper. The question, the diagram shows a part of the graph of y equal x squared. The normal to the curve at the point A, the coordinates 1, 1, meets the curve again at B. Angle AOB is denoted by alpha. The diagram given, they determine the coordinates of B, hence determine the exact value of tan alpha. I'll just resketch the diagram and let's start the question. The first part is the determine the coordinates of B. What we know that the tangent or normal to the curve at A, in other words, is normal to the tangent. So if you do get the tangent, gradient of the tangent at A, that is dy over dx. That's why we know that, the curve equation. So dy over dx at 0.11, it will give us the value of the tangent, the gradient of the tangent. So dy over dx is simply 2x differentiation 2x differentiation x squared is 2x, and substitute 1. So the tangent, the gradient of the tangent is 2. If that's the case, the gradient of the normal is minus 1 over 2, because of if two lines are perpendicular each other, each gradients m1 and m2 equal minus 1. So m1 is 2. If you take m1 as 2, then m2 is minus 1 over 2. So the gradient of the normal we have found minus half. The gradient of the equation of AB we just wanted to find, because of we need to find the coordinates. So before that, we'll find the equation of AB, which is equation of normal. But that the AB's gradient, which we have found, is minus half. But there's a point A is on that line AB. So the equation, standard format, y minus 1 over x minus 1 equal minus half. So y minus 1 over x minus 1 is a gradient. That is equal gradient minus half. So if you could equate that or just cross multiply, 2 times y minus 1 equal minus 1 times x minus 1. 2y minus 2 equal minus x plus 1. From that, 2y plus x, and bring 1 to this side, so minus 1. So minus 2 minus 1 minus 3 equals 0. That's the equation of the line AB. So we need to find B. So the line AB cuts the curve again. So in other words, the B should satisfy both the equation of AB as well as the curve. So AB meets y at y equal x squared at B. So substitute that y equal x squared to that, because to satisfy that point should satisfy both equation. So if I could actually substitute y equal x squared onto the equation 1, that's give us 2x squared plus x minus 1. From that, and you can see the factor, if you could factorize the left-hand side. The factors are simply just put across and then 2x x 3 minus 1. So 2x plus 3 times x minus 1. So x equal from the first one, x equal from that, x equal 2x minus 2x plus 3 equals 0. That x equal minus 3 over 2. The other one, x equal 1, that is represent point A. We don't need to worry about that. So this is the one. And then substitute that y, that is what y equal x squared. So y equal minus 3 over 2 squared, which is 9 over 4. So the coordinates of B is minus 3 over 2, 9 over 4. So we have found the first part, the answer for the first part. The second part, we need to find the tan alpha, the exact value of tan alpha. Tan alpha is the A or B. OA and OB lines. So if it, take OA as one line and OB as another one. So OA, it's a line which has the gradient. At the same time, OB, a line, has a gradient. But the line the OA makes with x-axis, we call it A. The line OB makes with the x-axis, B. So in other words, the gradient of OB is tan A. Gradient of OA is tan A. Gradient of OB is tan B. Let's establish on that. So tan B, that is the gradient of OB. We know the O coordinates is 0, 0. That is 0, 0. So the gradient is, we can find it, the gradient is what, 904, because of the y coordinates, minus 0 over minus 3 over 2 minus 0. And from that, if you simplify it, that tan B equal minus 3 over 2. Tan A is the gradient of OA. Again, 1 minus 0, because of A's coordinate is 1, 1. 1 minus 0, 1 minus 0 equal 1. That is tan A is 1. Alpha, if you look at the diagram, alpha is between OA and OB. In other words, alpha is B minus A. So alpha is B minus A. We use the tan both sides. Tan alpha equal tan B minus A. We know the trigonometry identity, which we all should know, the students should know. Tan B minus A is equal, on this, just tan B minus A, tan B minus tan A divided by 1 plus tan B tan A. But tan alpha equal tan B minus A. So it's tan alpha equal now is the tan B minus tan A over 1 plus tan B into tan A. But tan B, we found it minus 3 over 2. Tan A, we found it 1. So 3 minus 3 over 2, minus 3 over 2 minus 1 divided by 1 plus tan B is minus 3 over 2, tan A is 1. If you could simplify it, the numerator is 2.5, it's minus 5 over 2. The denominator is 1 plus 3 over 2 is minus half. So minus minus cancelled out. 5 over 2 divided by half is 5. So tan alpha is 5. Exact value of tan alpha. They didn't ask us to find the alpha. It's tan alpha they want us to find, which is 5. Thank you. Please subscribe the channel and share the contents with your friends and other students. Thank you.